Hello and good day. In pre-algebra, we're covering CO12, going over some answers before going on to the final objective of our unit, CO13, which also has to do with roots. So your job here, we filled these tables up on the top of the page with all the perfect squares, all the square roots that we'll be using, and you kind of had to apply those to end order of operations to these questions down here. So 7 squared is 49. And then minus 4, that gives us 45 as an answer, 45. The next one, 6 squared is 36, and then we're multiplying that by 2. So order of operations here, you should be multiplying 36 by 2 before adding the 12. Okay? If you got the answer of 96, then you added 12 and 36 first, and then doubled that. But that's out of the order of operations. Instead, you're multiplying to get 72, then adding 12, 84 should be your answer, 84. The third one we did together, we talked about how we can rewrite this to be the root of the numerator over the root of the denominator, and that gives us 6/11ths. Just take the root of each of them separately. Okay, nice thing that you're able to do with fractions. There will be one like this on your test. Okay. So you had a couple other examples down here in the last one, but there will be the root of a fraction. So you might want to jot down how to handle that. The last one in this row, the root of 81 is 9 plus 14 plus 5, and that gives us 28 as an answer there. Questions on that first row? All right, second row, 15 squared is 225. We're subtracting 14 squared, which is 196, and we're adding 13 squared, which is 169. 198, is that right? Yeah. Is that what folks got? Okay. The next one, 5 squared divided by the root of 25. So 5 squared is 25 divided by the root of 25, which is 5. So we end up with 25 divided by 5, and 5 is our answer for that one. The next one we did together, this 1 to the 8th is just 1. 3 to the 4th is 81, and then we're adding 8. So order of operations, we're multiplying first. 1 times 81 is 81, and then plus 8, 89 is what you should get, 89. And lastly, we started this together, and where we got was 10/7 plus 5/3, and then we were doubling that. And you had to take it from there. So what common denominator did you use to be able to add those fractions together? What common denominator did you use, Connor?
4 to the second power.
Sorry?
4 to the second power.
4 to the second power? For a common denominator? Okay. Common denominator. Maggie? 21. So multiplying what you need to multiply to get that common denominator, we get 30 21sts plus 35 21sts, which gives us 65 21sts. Okay? So that's that fraction inside of the parentheses that we get, and then we have to multiply it by 2. How would you multiply a fraction like 65 21sts by 2? Annika. Right. Okay. Remember that the value of 2 can be written as 2 over 1. So we're going to write times 2 over 1. I didn't write that very clearly. I'll do it over here. So we have 65 21sts times 2 over 1. And to multiply fractions, we just go straight across, right? So we end up doubling the numerator to get 130. The denominator, 21 times 1, stays the same. And so we get 130 over 21, right? So if you got the 65 21sts correct, then you added your fractions correctly. Everything was good there. But then the next step was multiplying that by the root of 4, multiplying by 2, writing that as 2 over 1. Gets us 130 as a numerator and 21 as a denominator. Okay? Questions on any of those, particularly that last one? No? We're good? All right. Then the very last one, using an exponent in one and a radical in the other, write two expressions that each equal the page number, which the page number on this page is 22. So give me an expression that you used, either one, either the one with an exponent or the one with a radical. Yeah. Good. 5 squared minus 3, 25 minus 3, that equals 22. Give me what you put. Yes, Ifan. Good. The square root of 121 is 11, plus 11 gives us 22. Any others? Yeah. The root of 25, so the root of 25 minus 3, that's going to give us 5 minus 3, which is equal to 2. So maybe throw on a plus 20 on the end of that or something to get that 22. Okay? Yeah, Aiden. The root of 100, which is 10, plus 12, that gives us 22. Good. Good. Okay. So CO13 is going to still be in the realm of roots, but we're going to be looking at, instead of perfect squares, non-perfect squares. And we've seen non-perfect squares before when we did rational and irrational numbers. But our goal today is not only to recognize a non-perfect square and classify it, but recognize a non-perfect square and estimate its value. Okay? It's not a perfect square, so we're not going to be able to get it exactly, but we want to estimate it as closely as we can. So we start here, and again, we're on CO13 now, so flip your page over. The area of a square is 25 yards squared. What is the measure of its sides, and how do you know? If I give you a square that has an area of 25, are you able to tell me what its side lengths are, and then tell me how you know? And the fact that it's a square is kind of important here, right? Because how do we find the area of a square? What's the formula, Connor? Base times height, right? Typically, the base times the height of a square will equal the area, yes? Now, the fact that it's a square, though, tells us what about the base and the height? Price. The price is right. Yeah, it means that the base and the height are actually the same. So if you know what the base is, you can really just multiply the base times itself to equal the area. I tried to turn that H into a B. It didn't really work very well. Okay? The base times itself is going to equal the area. So if we know the area of this square is 25, what number times itself gives us 25? 5. So we would know that the base would be 5 and the side lengths of this square would be 5. Right? Another way to think about that, is we just kind of did the definition of what a square root is. What number times itself equals 25? If we know the area of a square is 25, taking the root of that area will give us the length of the base, because by definition, we're looking for what number times itself. Right? This wouldn't work with a rectangle, because in a rectangle, base and height are different. It wouldn't work with a triangle because, that's base times height, then you got the half in there too. But with a square specifically, okay, knowing that those two side lengths are the same, we can take the root of the area to get the length of that side. Follow me so far? Okay? So then if we kind of ramp this up a little bit and say, well, what are the side lengths of a square with an area of 34? Well, that's a little bit harder, because what number times itself equals 34? 5 times 5 is 25. 6 times 6 is 36. There's nothing that works out evenly. Okay, so that's going to be our objective today is how can we estimate the value, for example, of the root of 34. It's the first one on here. So let's look at our practice section here. Okay, we want to estimate what the root of 34 is. And I note that CO12 here, the perfect squares on CO12 are definitely going to help you. Okay, because we know that the perfect square smaller than 34, the next perfect square smaller than 34 is what? The next perfect square smaller than 34 is what? 25, right? And we know the value of 25 is 5, yes? What's the next largest perfect square after 34? G? 36. And we know the value of 36 is 6, right? So it stands to reason that because the root of 34 is in between 25 and 36, root 25 and root 36, then the value of the root of 34 is going to be somewhere between 5 and 6. Because we're a little bit less than root 36, meaning we're a little bit less than 6. We're greater than root 25, meaning we're greater than 5. It's going to fall somewhere within that range between 5 and 6. Okay? So now our question becomes where? Is it right in the middle? Is it going to be 5.5? Is it going to be 5.1? Is it going to be 5.9? How can we tell where in this range of between 5 and 6 the root 34 is going to be? Aiden? And how? What clues can we use here?
How close it is to which side?
Ah, very good. Okay. 34, I think we can all be in agreement here, is closer to 36 than it is to 25, right? In fact, it's only 2 away from 36, whereas it's 9 away from 25. So because it's closer to the root of 36, is it going to be closer to 5 or closer to 6? Closer to 6. And here's where we get to estimate. Maybe it's 5.7. Maybe it's 5.8. Perhaps it's even 5.9. But if you were to put 5.5 down as an answer, I wouldn't accept that as correct because it's clearly closer to 36. And 5.5 is right in the middle, and it's not there. If you put 5.2, I'd mark that wrong as well because 5.2 is closer to 5 than it is to 6, and clearly we're on that closer to 6 side. Okay? So, if you've got a square with an area of 34, its side lengths probably around 5.8. And if you multiply 5.8 by 5.8 in your calculator, which is what you would do to find the area of a square with a side length of 5.8, what do you come up with, Aiden? Oh, sorry? 33.64, that's pretty close. Okay? For an estimation, that's pretty close. On a test, I'd accept either of those answers, 5.7, 5.8, 5.9. They're all in that ballpark there. But I would not accept something like 5.5 because root 34 is not halfway between 25 and 36. Follow me? We're good? Okay. And so I've said this before, and I'll say it again, that perfect square list on CO12 is going to be very, very helpful. Because the next one that we're going to, 180, you need to find the perfect squares that root 180 is in between. What's the next smallest perfect square? What's the next largest perfect square? What are they? Price. The price is right. I'm sorry. I'm going to say that forever now. It's just, yeah. We have the root of 169, and we have the root of 196. Right? Root 180 falls between them. We want the next smallest and the next largest. And because we know that the value of the root of 169 is 13, and we know that the value of root 196 is 14, we can say that the root of 180 is going to be somewhere between them. somewhere between 13 and 14. So where? Is it closer to 13 or closer to 14? Carly? Closer to 13. We're only 11 away from 13, and we're 16 away from, or 11 away from 169. We're 16 away from 196. So this one's kind of closer to being in the middle, right? Because 11 and 16 are fairly close together, but it's still going to be something like 13.2, 13.3. I would also accept, what? What did I do? I would also accept 13.4, okay? I wouldn't take 13.5 because it's not in the middle. It is closer to 13, but we can go up to 13.4, okay? Any questions on this that you have? Yeah.
When I did like 13 times 3 and 13.3 times 13.3, I got like 176.88.
And 176, the higher that we get, kind of the wider range of numbers that you'll find here. 176 is close to 180. That's why it's an estimation. A better answer would be 13.4. If you take 13.4 times 13.4, you'll probably get closer to 180. But for an estimation, only being 4 off is fine. Okay. Did you do 13.4 times? What'd you get? 0.56? Yeah. So, and if you wrote 13.2, you'd be further away, probably about 172-ish, 171. But at least you're on the correct side of half. It is closer to 13 than it is to 14. Okay. Okay, another one on the page. Anywhere on this first page that you'd like to do together, John?
I'm asking about each square root the nearest set and locate the value on a number.
Oh yeah. So the one piece of that. This is kind of like a number line that we have here between 5 and 6. So 5.7, 5.8, 5.9. You might want to put a dot somewhere to there where about 5.7, 5.8, 5.9 is. 13.2, 13.3, 13.4, locate it somewhere around there. Okay. Yeah, you don't have to make a whole fancy number line, just that is enough. All right, any others on this page you'd like to do together? Yes. Root of 5. Okay. So the root of 5, which two perfect squares does the root 5 fall between? Probably 4 and 9. Okay. So root 4 is the next smallest. Root 9 is the next largest. We know that the root of 4 is 2. We know the root of 9 is 3. So the root of 5 is going to be somewhere between 2 and 3. Is it closer to 2 or closer to 3? Connor? Closer to 2. Because 5 is only 1 away from 4, and it's 4 away from 9. So what might you write down as an estimated value here? Connor? 2. I was like 2.1, 2.2, 2.3. It's probably in the 2.1, 2.2 range. If someone's got a calculator and wants to test those out, see which one is the closer answer. Probably 2.2, actually, but 2.3 would be acceptable as well. So it's somewhere right around there. Okay. Anyone check it? Did you do 2.1 or 2.2?
2.2 is 4.80.
Ooh, that's pretty close. Yeah, so 2.2 times 2.2 is about 4.8, which is pretty close to 5. So the root of 5 is going to be about 2.2. Okay? All right. Any others? Yes.
I don't understand how you get like the decimal.
The 2.1, 2.2, 2.3 thing. So, if we were to, I'm going to draw this number line out a little bit larger here just so I can write more stuff. But the numbers between 2 and 3, halfway between 2 and 3 is going to be 2.5, right? And then here's 2.1, 2.2, 2.3, 2.4, okay? And over here is 2.6, 2.7, right? All the way up to 3, okay? So if I know that the root of 5 is closer to the root of 4 than it is to the root of 9, because it's only 1 away there and 4 away from 9, that means that the root of 5 is going to be closer to 2 than it is to 3. It's not going to be at 2.5, because 2.5 is right in the middle between 2 and 3. But root 5 is closer to 2. So it's going to be somewhere on this side of half, and then we're just estimating. It's only one number away from 4, so it's going to be just a little bit greater than 2. So it's going to be somewhere down in this range here. Okay? Just like with this 13 and 14 here, I saw that 180 is closer to 169, so it's going to be closer to 13 than it is to 14. And so the numbers that are in between 13 and 14, 13.2, 13.3, 13.4, they're all closer to 13, right? This first one, I knew it was going to be closer to 6, so it's going to be on the right side of half, if you want to think about it. So 5.7, 5.8, 5.9 are all closer to 6 than they are to 5. Does that help? Okay. Any others on this page to talk about? Connor? Yes, you will be doing all of them. So if you want to do some together now in class
In the back.
to get them done. And the second page is paid as well. Yep. Yeah.
Like on the bottom, is it just the same thing?
It's the same thing. Yep. The second section here is the exact same thing. Note it does say to show your work. Okay. So you need to be showing me the perfect squares on both sides of it, just like we did in the examples. Okay. I need to see that. I need to see, so for root 94, show me your root 81. Show me your root 100. Show me that root 81's 9. Show me root 100's 10. Okay, show me which one it's closer to. 94 is closer to 100. Therefore, it's going to be closer to 10. And so when you place your dot closer to 10, then you might think 9.6, 9.7, 9.8. Those are the numbers that are between 9 and 10 that are closer to 10. Okay, so that's the work that I need to see here. Right? That is correct. Yes, that is correct. And there is a section on the second page too that I want to talk about briefly before we depart. So get your notes down here and flip over to the second page. The top section of the second page is the same as the first page. You might be thinking, geez, this is kind of a lot of repetitions, do the same thing over and over again. It is. Historically, this objective on your upcoming test is the lowest scoring one. So I want to give you practice after practice after practice, just so it becomes just more automatic. But then this middle section here says, now we're going to shift our thinking and work backwards. For each decimal below, estimate its value written as a square root. Written as a square root. So now it's like I'm giving you the answer, and you're giving me, what possible starting root would that be? Another way to think about it is, if 2.7 is the answer, what's 2.7 times 2.7 approximately? If we know that 2 times 2 is 4, and 3 times 3 is 9. What do you suppose 2.7 times 2.7 is going to be, approximately?
7,
Maybe 7?
8.
Maybe 8, right? So then your answer would be, well, it's root of 7, root of 8. It's not going to be root 9 because the root of 9 is 3, and we're definitely, 2.7 is less than 3. It's not going to be 5 because, as we saw in the example we did previously, 2.7 is closer to 3 than it is to 2, and the root of 5 is closer to 2 than it is to 3, right? 6.1. What root would give us a value of about 6.1? We know that 6 times 6 is 36, so it's bigger than that. We know that 7 times 7 is 49, so it's less than that. What do you think? Where between 36 and 49 would 6.1 times 6.1 land us? It's not going to be like root 48, right? Because root 48 is very close to 49, so that'd be like 6.9 times 6.9. Annika?
37 and 38.
Sure. It's 6.1 is just a little bit bigger than 6, so our root is going to be a little bit bigger than 36. Root 37, root 38, I even take root 39, right? Somewhere in that range. Okay? So in this section here, you're kind of working backwards. Then 2 questions at the bottom. Through your grandparents, you find out your family owns a large plot of land in rural Minnesota. An old map they have shows the plot to be a square with an area of 200 square miles. So here's what we have. Right? Kind of similar to how we started the objective today. You have a square with a given area. In this case, it's 200. The length and width of the plot, however, have faded. So you can't see what the length and width of this square plot of land. Approximately how many miles long and wide is the plot of land? Okay. And then lastly, a square bulletin board has an area of 66 feet squared. What is the length of one of its sides? Again, the fact that we're dealing with a square bulletin board is important. If you read these questions and you're thinking, I don't know what I got to do here, remember what objective we're doing right now, right? What was the I can statement, right? I can estimate a non-perfect square. We started the lesson with areas of squares, so you can kind of refer back to that. But you're doing the same stuff, just in a real world context. Final call for any others you want me to do with you now. Last chance. Yes. So this last one here, that square bulletin board of 66. Oh, and there's one below that too. My goodness. Page is larger than I thought. Square bulletin board, an area of 66. Okay. Looking for one of its sides. Again, the fact that it's a square means you're looking for, because the base is the same as the height, so really just what number times itself equals 66. Another way to think about that, this is the definition of a square root, right? What times itself? So you're essentially going to be estimating the root of 66. Same thing that you did on the rest of the page. And below that, a square garden has an area of 42. How many feet of fence do you need to enclose the garden? So in this case, you're still looking for the side length of it. You're still looking to estimate the root of 42 to get what the length of the square is. But then what am I really asking for? When I say how many feet of fence do you need to enclose the garden? What is that referring to? Sarah? Perimeter, right? So once you estimate the root of 42 to get what a length, a side length of the square is, now you've got to use that to find the perimeter of the square. So the last one is one little extra step. So there you go, CO13. We'll check it in tomorrow. You'll get your practice test tomorrow. You'll have that to do over the weekend. We'll go over the practice test in its entirety on Monday, as well as do a little review game, and then plan on your test. Sans calculator, so no calculator allowed for this second one also on Tuesday. And that, folks, is How You Math.